The telescope's sunshield will be the size of a tennis court.
The James Webb Telescope has a very large sunshield. In fact, it's the size of a tennis court. The sunshield will keep the telescope cool enough to operate with infrared energy. NASA believes Webb's operating temperature is less than 50 degrees above absolute zero, 50 Kelvin 223 dig C or 370 dig F. Therefore, Webb has a large shield that blocks the light from the Sun and Earth and the Moon, which otherwise would heat up the telescope and interfere with the observations. Webb will be placed in orbit around the Sun at a special location where its sunshield can block both the Sun and Earth and Moon all the time.
3 space agencies will get credit for the project.
NASA spearheaded the James Webb Telescope mission and developed the craft for over a decade, but the agency also collaborated with the European Space Agency and the Canadian Space Agency on the project. This is not the first time NASA received contributions from other space agencies. The American agency worked with the European organization on the Hubble telescope. Northrop Grumman contractors developed the spacecraft bus and sunshield.
The Webb Telescope will embark on a relatively short mission.
While the James Webb Telescope, NASA designed the Webb for a 5-year mission in space with a goal of extending it to 10 years. The length of the Webb's mission will depend on 2 main factors: the amount of fuel it uses during orbit and whether any instruments on the telescope malfunctions. Unlike the Hubble, the Webb won't be serviceable. Astronauts won't be able to fix any damages once the mission begins.
The Webb Telescope will cost billions of dollars to make.
The James Webb Telescope cost $8 billion, and it's a NASA flagship mission. The flagship program is one of NASA's 3 programs. The other 2 are New Frontiers and Discovery that explore the solar system. This program funds the most expensive missions. In fact, flagship missions usually cost much more than $1 billion.
The Webb Telescope is named after the second administrator of NASA.
The James Webb Telescope is named after James Webb, the second administrator of NASA. He led the agency from February 14, 1961 to October 7, 1968. Managed NASA during both Mercury missions that sent the first humans to space. He also oversaw the early Apollo missions, which eventually placed men on the Moon. In fact, Neil Armstrong took his first step on the crater-filled orb less than a year after Administrator Webb stepped down from his position. The Webb Telescope was originally called the Next Generation Space Telescope.
The Webb Telescope will not orbit Earth.
Unlike the Hubble telescope, instead, it will maintain an orbit between Earth and the Sun in a cold location in space known as L2. The Webb will travel to L2 primarily because the telescope must be very cool in order to operate correctly. NASA says Webb will observe primarily the infrared light from faint and very distant objects. Infrared is heat radiation, so all warm things, including telescopes, emit infrared light. To avoid swamping the very faint astronomical signals with radiation from the telescope and its instruments must be very cold.
The project will take years to complete.
Specialists started working on the James Webb Telescope in 1996. It's a successor to the Hubble Space Telescope, which has been one of NASA's key observatories since 1990. Although the Hubble could remain active until 2040, NASA began developing a successor as early as the mid-1990s. The Webb project was conceived during NASA's push to develop a low-cost telescope that was faster, better, cheaper. Former agency director Dan Goldin coined that motto.
The Webb telescope will work with a different wavelength.
Since the James Webb Telescope is designed to see infrared light, it will detect light on a different wavelength than other telescopes. Infrared light's 3 regions on the electromagnetic spectrum emit at longer wavelengths than visible light. Near-infrared is 7 to 5 microns, mid-infrared is 5 to 30 microns, and far-infrared is 30 to 1000 microns. The Webb will be able to see on a wavelength of 6 to 28 microns, meaning it will be able to observe objects in the mid-infrared regions.
The Webb telescope will launch in 2019.
The James Webb Telescope leaves on its mission in spring 2019. According to NASA, the Webb will launch from French Guiana on an Ariane 5 rocket, a European heavy-lift launch vehicle. The launch site is called Kourou ELA-3, or the Guiana Space Center.
The Webb telescope will also investigate brown dwarfs.
The Webb telescope will also investigate brown dwarfs. The Webb telescope will primarily observe the infrared spectrum.
The Webb telescope might find water on exoplanets.
The Webb telescope might find water on exoplanets.
The Webb telescope will look for signs of life on Europa and Enceladus.
The Webb telescope will look for signs of life on Europa and Enceladus. The Webb telescope might allow scientists to see the formation of the first galaxies.
The Webb telescope will see farther than the Hubble telescope.
The Webb telescope will see farther than the Hubble telescope.
Hey guys, thank you so much for the support and likes and comments down below, and also thank you so much for watching, and I look forward to see you in the next video. Then take care, bye.